So how many of you guys here have worked with networking gear in the past? Cool. All right. Quite a number of you. So with traditional networking gear, you have, as most of you probably already know, you have pretty expensive hardware, and usually it's some kind of vendor lock-in. And they have proprietary interface, and change normally is manual, repetitive, and error-prone. So, and over time, your configuration gets drift. A lot of people solve this by running Rancid or something like that, where you do some sort of revision control. But all in all, it's pretty difficult to do some kind of automation with it and testing with it. So combining CHEP and networking is interesting and difficult until sort of now. So this is how the command line interface typically look if you look at a switch or router. In this case, just a simple BGP setup between two peers, and another one, it's just an example of a VLAN configuration on a switch. In this, there's a lot of implicit meaning, especially on the Cisco devices. Juniper sort of got away from these by making everything is more explicit, and that transition sometimes can be interesting. But onto CHEP. So this is sort of the CHEP and test kitchen pattern that we have here at Ooyala. So we do testing locally on the test kitchen, and spin up a box, put on the cookbook, iterate, and then push the commit and grocery delivery, send it to CHEP server, and eventually go to the switches. The switches we're using in this case is Cumulus switches. They basically white box machine that run a variant of Linux distribution on it. Currently they're running it on Debian. And so it is off of PowerPC, but CHEP is run natively on it, just like the typical Linux server. So from then on, it's exactly like how you would deploy to your server. So in this talk, I'm going to go over a quick example of how we do it here. Our network is built to be pretty simple. We have a leaf and spine design, basically fully layer 3. We don't run any kind of layer 2 network across it, and we use ECMP for routing between leaf node to spine node, and we can add the spine horizontally as we expanded it. Same thing for the leaf nodes. So this is sort of the design we go off of. We don't span VLAN across and then use any kind of proprietary protocol to carry that VLAN across. HA is all done because it's stateless and because of ECMP between two nodes. So your packet go from a host to a leaf. It could travel either between spine 1 or spine 2 or both at the same time. So for any kind of functional network that needed to be on top of that, we basically opt to go with virtualized networking on top of it, but we're going to leave the physical design very, very simple. So that's sort of our reference design. With Cumulus, almost everything you've done is, actually everything you've done is at Linux. They have a daemon that sits there, and then after you do like ifconfig on your port, they're going to take that configuration, download to the ASICs, and then your flow will be on hardware within microsecond. So one of the first cookbook that we open source is basically to take the model of whatever hardware that you are on at this time. In this case, we're doing it for AS6701 32 port Acton switch. Basically, this ASIC, there's two pipelines on that ASIC, and so when you pass the two pipeline info, we basically turn one of the 40 gig port, like port 21 to port 24 on the front panel, to be 4 10 gig port each. So now we just basically reprogram that switch with chip to be basically 10 gig ports. This is the so on to the next example. This is the second cookbook that we also released, is Quagga. Basically, we take a bunch of data that we construct and then sort of bind them together and then send it to Quagga, a provider for it. So this is an example of setting up a eBGP configuration on one of the SPI switch that you saw earlier in this diagram. Sorry, this one right here. So now I'm going to go to the demo. Basically, currently on a test, I don't want to run it on the whole switch because right now it takes about 12 minutes just for the run. We need to shorten up the time on a lot of these cookbooks, and especially because these switches, they don't come with a lot of CPU power, so that's why it takes about 12 minutes. But that's the time that I measure. But we also have a lot of our cookbook running on it. For example, setting up time, setting up syslog, setting up all the functionality that you would normally do on your server. Now you sort of run it on your Linux. So that's the screen. Hopefully you can see this. So basically, I'm going to do a kitchen run on what would happen if you run a Quagga interface on it. Sorry, I can't see.
Type on the word kitchen.
So this is one of the projects I set in kitchen for right before the demo. So I'm going to do a kitchen. And then I'm going to log into the system afterwards. So basically, when you run the Cumulus Linux cookbook and you run it on a non-Cumulus system, it's going to mock the interfaces. It's going to build up the port so that you can start doing like development on it. So you can do OSPF configuration, test it out, and then when you actually run the same cookbook on the Cumulus system, right now I'm sort of working with Mina on how to best detect, when you're on an actual Cumulus system. I think they submitted some patch that OHI can return Cumulus today to get that you are on the system. So I just ran it. Basically, you're going to set up a bunch of ports. So I'm going So in here, you see that the mock interface are basically set up with the IP. For example, the 1051A, 10101, A74, those are the mock interface that set up on the virtual box, but then when you run it on the Cumulus system, you have the exact same configuration. So now you can go look at the routing daemon. You'll see and that's the quagga that's set up by the two cookbook that I have. Also, basically, these are the two cookbooks that I have. In this cookbook, it's just a wrapper around the two cookbooks that we released, Cumulus Linux and Quagga. So this one basically set up some test support and another cookbook that run as one of our actual production switch. So it's set up the pipeline for the for Cumulus, and then set up basically for the port to be 10 gig port. So that's all I have for the presentation. You should download and try out the cookbook release. So this is the first time I know of anybody who runs Chef on a Linux device, so I'm pretty excited about it to share with you guys. So I'm up for question now.
If anybody has a question, happy to run around the mic or what have you, or we're in a pretty small room, you can probably jump up and ask. But
So you're saying these switches are some kind of white box switch that you made yourself, but what about more proprietary hardware? Have you done anything with that, or do you know anyone's? So
these switches, Cumulus probably can tell you a little bit more about it, but these switches are basically OEM boxes that have the exact same board layout as some of the switches that you can buy on the market today. So for example, KFX 5100 from Juniper run Broadcom 2 chipset, which is the exact same chipset that being built and run on the Acton 5103 here. I didn't build anything special. Cumulus, the one who released open source the Omni installer, which basically like a BIOS for the switches, and you run install Cumulus Linux on top of that, and then because it's a Debian distribution of Linux, you run Chef on it.
So your suggestion is just use this type of hardware, don't use the Cisco switch?
It's for our case, we want to build something that very vendor agnostic, use standard protocol like OSPF and BGP. I think in this kind of thinking, we can drop in pretty much any device that support those two protocol for our case. And for integration with Chef, that's the sort of the missing part that we don't have before. So that's the interesting part.
you should be able to expand this to really any switch that can run Chef on it, like the Junipers and some other folks in the world have started to extend their systems to allow this type of a thing. Bao's just built some really awesome cookbooks that make it easy. And I mean, the reason we went with Cumulus was we've actually done like the whole open compute platform hardware stack. We get these pre-built racks with all of the gear in them, and it was just a perfect fit for Cumulus.
Yeah, and also Cumulus, they embrace the layer 3 design that like a lot of larger companies now starting to move towards, because on the layer 2 design, you don't get to scale it in a way that you like without resorting to some kind of proprietary protocol.
Thank you.
Sure.
Is most or all of your production environment using this?
So our previous generation cluster used Juniper, and our new build will be off of Cumulus switches.
If the question is, are we using this in yes, we are. It's powering traffic that powers when you watch video online right now.
Does your mock cookbook actually work functionally if you were to build a test case of actually routing traffic to confirm that you did the right configuration, or is the mock cookbook that you use in kitchen just mocks it?
Good question. So in the mock cookbook, I use the dummy interface. Dummy interface is interesting because you don't have the physical port. The dummy interface will work in terms of the logical interface. So let's say you want to advertise the route on Quadra using dummy interface. It will exist and it will advertise it, but there's no physical port for packet to forward to, so it wouldn't work in that case. But all your logical testing should emulate pretty much like you are if you are running on a real system.
So you can't build in kitchen like the leaf spine core architecture and actually observe.
Yeah, you could, but you have to use more of a like actual virtual NIC interface for that. And I don't like in VirtualBox. I think you have to do quite a bit of mapping and such to build a full structure like that. But yeah, we do use dummy interface as a way to advertise loopback interface on our production system. So it's not like a fake interface per se.
Thank you.
As was said, my name is Tom Duffield, and I am a software engineer with Chef. I am also the lead developer on the on the project called Chef Container. I'm going to mute that. Okay, there we go. And maybe we can fix that. Okay, so I'm going to talk tonight about how you can use Chef Container to leverage configuration management in your container workflow. The rough agenda for tonight is, first off, I'm going to kind of help you understand some Docker mentalities that helped drive how we created and why we created Chef Container. I'll go into Chef Container, talk a little bit about some of the gaps that it can fill with just plain old vanilla Docker, and then talk about how the benefits of integrating it with the knife plugin knife container and how that workflow can help you. So the first bit is Docker mentalities. So if you've used Docker, you've probably heard the term process isolation. And this is essentially using your Docker container to distribute applications. This is the pattern that Docker kind of touts. And its main identifier is that your PID1, your first process, is the application runtime itself. There's usually no other processes that aren't directly related to that PID1. This, you can kind of think about this as kind of like treating a Docker container like a Java war. It's just an isolated bit of your application. The other way that most people use Docker is as an infrastructure container, or kind of using a container as a lightweight VM. This is usually, you can usually see this by the fact that the PID1 is some mysterious init scheme, and you have more than one process that may or may not be related. So in this container, you'd have Chef Client running with Apache 2, with your Nagios for monitoring, your Logstash for log aggregating. So you'd have multiple processes that aren't directly related to the purpose of the container running inside the container. So the PID1 here, the command, is actually a question mark, because this is something that is commonly referred to as the PID1 problem. And essentially what that means is when you specify a command when you run via Docker run, that command must tell the container what processes it should run, and that process is responsible for properly managing all of its child processes. So you need to make sure that whatever command that you put in Docker run can clean up after itself. This is kind of what Chef Container was designed to solve. So, Chef Container. Chef Container allows you to do multiple things. One is you can use Chef to configure your container images. You can, instead of having to use a Docker file with a bunch of bash commands to install your applications and drop off templates and all that type of stuff, you can actually use any existing Chef recipe straight off the supermarket and run it in your container and have it configured. No modifications. You can also then idempotently manage the running state of your container. You can actually now, if you want to, run the Chef client as a daemon in your running container every so often and actually have it manage your running state. And it also, then because it can do that, it can also help you safely manage multiple services inside of your container. So Chef Container is great if you have to configure very complex applications. If it's something that, despite your best efforts, just requires too much bash hackery to get it to work in a Docker file, you can use the existing Chef resources to do that. It's also fantastic if you're transitioning from a more traditional architecture to containers. If you have a run list that you know works when you run it on Amazon or CloudStack or whatever it is, you can just take that run list and put it into a container and have it work. So it's great for that transition. It's also fantastic for applications that have last mile configuration. When you launch it for configuration that you cannot do during the build, it has to be done after the container is launched. Maybe that is environment-specific configuration. Maybe you need to determine whether or not your container needs to talk to the US East endpoint of Amazon or the US West endpoint of Amazon. Or you need to register some agent with some other service, and that can't be done during the build. All of this gives you consistency across architectures. You can now use the same configuration management tool, whether it's a physical, virtual, cloud, or a container instance. So you don't have to manage multiple code types, if you will. And because you can use it across all of these architectures, you can actually have a mixed architecture application. You can leverage Docker for development and test, even if your application isn't hosted in a container in production. So, what is Chef Container actually made up of? Chef Container is an omnibus package with off-the-shelf Chef client, the same Chef client that you could download today with no modifications. The Runit, which is the same Runit that we currently use to manage services in the Chef server, and Chef-init. Chef-init is the magic gem that I wrote that kind of glues everything together. So Runit provides you with a lightweight cross-platform init scheme that you can use to ensure all of your processes are properly managed. So instead of writing yet another init scheme, we just decided to leverage Runit. So if you've used Docker at all, you know that the normal init scheme that comes with your platform is essentially overwritten. You no longer have an init running in your container. So if you want to have multiple processes being managed, you have to provide a new one. And that's what Chef-init does. Chef-init is your PID1 that basically passes all of the responsibility for managing the multiple resources onto Runit. So if Chef-init is your PID1, Chef-init also provides you with an idempotent method to specify multiple actions that you want to have when your container launches. So now, what you can do is, when you launch your container and you specify Chef-init on boot, which in this case is the command you would use when you run your container, two things happen. First is Chef-init launches run svdir, so it launches Runit. So now you have a process to manage all of your services that get launched. And then it runs Chef client. Then it just kind of waits until it receives a signal from the host to tell Runit to shut down. So Runit will handle shutting down all of your processes, and then it exits out of your container. So now I mentioned services, and for anyone who's used Runit before, you know that Runit has a different way of handling services than your typical init scheme does. So what that means is you have two different types of services when you're running in Chef Container. The first is an unmanaged service, and this is a service resource that is just in your recipe. It will still work, but what will happen is, because it doesn't have an init PID to register with, the parent PID of your running service would be Chef-init. Your service would run just fine, But the only thing is, there's nothing to manage it. If it's stopped, there's nothing that'll restart it. All of your normal service your service resource actions will still work, but there's just nothing to manage that process to either cleanly restart it or cleanly shut it down when you kill your container. So to get a managed process, all you need to do is add a node attribute somewhere in your attribute precedence stack. It can be in a cookbook, in your role, environment, whatever. Essentially what you do is the container service level is a reserved level, and then you specify the resource name in the second level. So here's Apache 2, and you have command, and then you give it the run it command that you want chef-init to tell run it to use to manage that service. And what will happen is the chef-init libraries that are automatically included when you run chef container will basically override the service resource and have all of the actions now go through a custom provider that will result in basically your service now being managed by run it. So what this means is you don't have to use an LWRP to have your service managed by run it. It happens automatically just by the addition of this node attribute. And the great thing is this node attribute can be in your cookbook itself because it will be ignored in any environment that isn't running chef-init. So you can actually, if every community cookbook owner can put their run it command in their cookbook, and everyone would be happy. Another thing is all of this means that Chef Container is a vendor-agnostic container configuration solution. You can use it anywhere where you control what PID1 is. So it works in Docker. It should work in LXC, jails, zones, wherever you specify what PID1 is, you can use Chef Container. You can even use it if Windows comes out with their Windows container and Mac comes out with their Mac container. It would be able to work. So it's not tied to a specific container implementation. So the knife container workflow. This is where stuff gets kind of cool. So knife container is just a gem that you can install. And it has this breakdown. You have knife container and then a tool and a subcommand. So the tool right now is only just Docker. But it could really be any tool that is part of a container workflow. You could integrate it with any container API, Mesos, Kubernetes, CoreOS, whatever. So you can control your container image from development to production through its entire life cycle with this tool. So I mentioned that Docker is really the only command that's out there right now since it's still in beta. So there are 3 different commands. There's init, build, and rebuild. And I'll go through each of them here. So init will generate a Docker context with all the necessary Docker components and Chef components. It will then pull down your base Docker image and tag it with the appropriate name. And that would look something like this. So you have knife container Docker init, and you specify your normal Docker tag, so you have a namespace and then an image name. And then you have a series of options. The most common ones are the -f flag to specify what your base image should be, the -r flag to specify your run list, the -z flag to specify whether or not you want that Docker image to run using Chef local mode. So you can have a container image that can either connect to a Chef server or run in isolation using Chef 0. And then, if you use Burkshelf, you can specify the -b flag, and a Burks file will be generated for you. So both Z and B are optional. And here's what happens. So you have, let's say, the Ubuntu-1204 base image that Chef provides with Chef Container pre-installed. When you run Docker init, it tags that same image ID with the image name that you passed in. So now you have 2 tags, both pointing to the same physical image ID. It will then generate the skeleton structure for your Docker context. By default, it'll create a Docker files directory in what knife determines to be your Chef repository. If you don't have a chef repo, you can set what you want that path to be in your knife.rb. It'll then generate a parent folder called for namespace and a child folder for image name. What this means is you can actually now hook this file structure up to a Docker automated build. Inside the image name folder, you'd have a chef directory, and that's where all of your chef files will go. Then you also have a Docker file. The secure directory is a slight modification to the chef paradigm. All of your secure credentials, your validator PEM, your encrypted data bag, your trusted certs, all of those are now kept in that secure folder. And by default, the secure folder is stripped out of your image before it's saved. So you don't have to worry about having your secure credentials being stored in an image and that image being uploaded to the Docker Hub for anyone to download. The next phase is Docker build, and this resolves chef dependencies, builds the Docker image, and then cleans up any chef artifacts. Knife container Docker build with just the image name. And what this does is your Docker file actually, instead of using Ubuntu 12.04 as the from, it uses your image name as the from. So your input and your output of your build process have the same tag. And what this means is that as you run build, you are actually building on your previous build. So it's an idempotent converge. So you're not converging from an empty image every time you run build. You're building from your last successful image build. And this has some really great ramifications. Let's say we have an installation process that requires 4 steps, A, B, C, and D. In a typical Docker file, you would have, let's say, 4 layers. Layer 1, Layer 2, Layer 3, and Layer 4. And let's say with a chef recipe, you'd have 4 resources, R1 through 4. As you go along and you build it, let's say you need to change step B. Because of how Docker handles its build cache, if you change B, you need to rebuild layers 2, 3, and 4. And when you distribute them, all of your engines would need to download layers 2, 3, and 4. But with Chef Container, because of how we handle the input and the output being an idempotent converge, you would only ever need to change R2, and you'll only ever need to download a new layer with just the R2 deltas in it. And that would look something like this. So version 1, you have 4 layers plus your base, and that 1 layer with the results of your first Chef client run. When you change that B step, you would need to download, rebuild and re-download layers 2, 3, and 4. But with version 2 of your image, all you would have is just another layer with only the deltas of what actually changed in your image, making your downloads much faster. Same happens when you need to add a step towards the beginning of your build. You add E before B, that would invalidate everything after that, so you would need to rebuild layers 5, 2, 3, and 4 with a Docker file. But with Chef Container and Knife Container, all you would need to do is just have a new layer with resource 5 in it, drastically decreasing the amount of information that you need to download when you're updating your Docker images on your Docker hosts. The last command is one that's going to be released as part of the version 1 release, and that is Docker rebuild. And this is essentially kind of a rebase in your build phase. So in your build, you have the input and the output being the same, but let's say we release a new version of Chef Client. We distribute a new Ubuntu 12.04 with the latest Chef Client, and you want to rebuild using that as a base. Or let's say you run into the AUFS layer limit, and you want to condense all of your layers down. You run rebuild, and what will happen is it will re-download and re-tag that base spot, that base image, delete that orphaned branch now, and rerun Knife Container Docker build. So now you've rebuilt off of a fresh base image. You've gotten rid of maybe some extra layers that you don't need anymore. You have the freshest base image, whatever it is. So in summary, fast and easy transitions from your existing architecture. You can use the same configuration model across various different containerization solutions and different types of architecture. All of that facilitates the mixed infrastructure environments. You can have dev and test and whatever all of your pre-prod be in Docker containers, while your production may be in something else. Item potency in your image build process and in your running containers. You don't need to do anything that doesn't already need to be done, your standard Chef benefits. And it also decreased overhead for your configuration changes. You don't have to rebuild and download potentially hundreds of megabytes of Docker layers for a simple change. So at this point, if you have any questions, I will be happy to take them. I can also go through a very quick demo, but if I know that we're kind of running a little bit late, so it's up to you. But first, are there any questions? Yes.
So, does it do anything where you can do multiple containers with the knife container command? Can you work as you have any level?
So the question was, does knife container right now support touching multiple containers? And the answer right now is no. It only will handle just that one container image building with Docker. But as it evolves, there's no reason why it couldn't. But right now, you just are controlling the flow of one Docker image through basically your build pipeline up through deploy to the Docker Hub or whatever your private Docker registry may be.
If I understand correctly, the first part was really good talk about Chef Init. That was awesome. If I understand correctly, your statement about speed, what you're basically proposing is to only append layers past the last successful build and rely on the fact that Chef will have guarantees about how its converge works. So it'll converge against the latest Docker image, but it will run a whole converge when you're building the next layer. Is that what you're proposing?
Yes, that's correct.
How realistic do you think that is in practice? Because that leads to like the garbage collection problem, where as people remove things from their Chef configuration, anything that's not explicitly tested for as part of the recipes will just persist in the older layers. So like, for instance, I wanted to change from I wanted to run a new daemon. I don't care about shutting down or removing the files for the old daemon. So presumably the test will work, but I'll keep building up cruft in the image. Right? Right.
So the idea that having basically continuing to append new layers onto your Docker image through the knife container Docker build will result in a lot of cruft. That's the purpose of knife Docker rebuild, is to remove that when you feel like you've gotten too much cruft.
So how can people feel? I mean, in the interest of automation, how would you feel it's time to do a rebuild versus, the traditional approach would be like do a full rebuild every time. And I understand like for the example of I just want to push this one file out, but it's an earlier recipe, how you can optimize for that case. But I mean, I'm just wondering how realistic it is to use that.
Determining when you should do a rebuild can be up to your team. You could follow the methodology that every build is a rebuild. You could follow a methodology that every release of a cookbook, like every new, like maybe your dev test cycle just builds on top, and then when you release to production, you do a full rebuild and you just push the full rebuild out. You can come up with your own process that best fits what your workflow could be. So yes, I know that there is that cruft in there, but when you're doing those small changes, I've had conversations with several different people, and the fact that it's so difficult and so time-consuming to have like a single change and have a huge impact on having to download huge layers, this can be a nice solution. So using rebuild isn't there isn't a set time frame of like you must rebuild every week or you must rebuild every 2 releases. It's kind of up to you about when you feel you should rebuild. But you have the option to choose when that happens. Good question. Any others? Yes. So I will now do a demo. If I can get that up there, minimize that. And
So, can I ask a question?
yes, of course.
How often Chef going to run in the container?
So by default, the Chef client will only run once when the container is launched. If you want to run it more than one time, use the Chef client cookbook to set it up to run as a daemon. So the Chef container makes no assumptions about how you want your container to work. The only assumption it does make is that it removes your validator path.
So at the end of that first convergence, it'll just disappear. Just leave the container as is, and that's it. And it's no longer going to be PID 1.
No, Chef init is always PID 1. Chef client would run and then disappear, yeah, because Chef client is a child process of Chef init.
And so who's gonna register the Chef to the server? The first time you run it in the image, or the first time you run it when you run the container?
So the question was, when does the container register with the Chef server? So the Chef, when you're talking to a Chef server, the container will register when you run a Docker build. It will register a build node, and then after your build is complete, it will delete that node from your server for cleanup purposes. After that, it will, every time you launch a new container, it will create a new node object and new client for each of those containers. So if you have 500 containers being launched, you now have 500 Chef nodes.
When I delete it, it will delete it from the Chef server?
No, unfortunately, I would love to be able to do that, but the problem is that from inside the container, there's no way to tell the difference between a stop, a kill, and a remove. So when I get a signal inside the container, I can't tell whether or not you just want to stop the container, want to restart it, or if you're actually removing the container with the intention of removing the node object. So unfortunately, right now, you have to clean up the node objects from outside of the container. We're currently working on a Chef Metal plugin, and my goal is for Chef Metal to be able to have the ability to manage the client from outside of the container, so it would launch the container and then do any cleanup that you need it to do. You could also, if you're using like the Docker cookbook right now with the Docker container LWRP, you could also have like some Ruby code in there that could delete the client. But unfortunately, right now, it can't be done from inside the container.
But that would go against the principle of encapsulating inside the container anyway, right? Because if you wouldn't want the container you wouldn't want the container to be the ultimate source of truth for whether it's allowed to destroy itself, right?
Some people may, some people
Yeah.
might not, but yeah, the concept of whether or not the container has the authority to be able to delete itself, like whether you want that to happen, especially when your containers are popping up like no other, it's an interesting question. Your viewpoints can differ, but unfortunately the reality is that the container can't kill itself, right? The container can't remove its own node object even if it wanted to right now. Okay, so I'm gonna go through the demo. If you have any other questions, please feel free to interrupt me and I'll answer them, but I'm basically gonna go through a very simple kind of hello world demo. So can everyone see this? Yes? Okay, cool. So, and that should, all right, I'm hoping it's showing for the people on the hangout. Anyways, so to get started, all you have to do is just download the knife container gem. That's all you need to do to get started. It's better if you have ChefTK. Personally, I believe that, but it will work with any Ruby environment as long as I think it's modern. Anyways, so you can install the gem, and then you can just get started with knife container. So knife container, Docker init, and then I want to give it a name. So I'm going to give this name demo nginx. So I'm going to spin up just an nginx image. So here I'm going to pass the -r flag and have it pass in the nginx recipe. Super simple. For speed, I'm going to have it use chef 0, and I want to generate a Burks file. So you can see the output here is very similar to what you would see with ChefDK's generate output. And here it has downloaded in this case, the default image, which is Ubuntu 12.04. We have currently images with Chef container pre-installed, Ubuntu 12.04, 14.04, CentOS 6 and 7, and Debian 6 and 7. So you could specify any one of those as your -f. So here now I'm going to run no modifications. I just want to go straight to building it. So I'm going to clear that so it's up top. Knife container, Docker build, demo, nginx.
I'm Docker ignorant. Are you running this on OS 10, or is this Linux?
So I'm using boot to Docker. So this is a Mac workstation, and I'm using boot to Docker to do all of the Docker stuff.
What's that?
Boot to Docker is essentially a VirtualBox VM with a minimized image that you can use to run Docker from your Mac or Windows operating system. But yes, right, because Docker is limited to just the Linux kernel, but with boot to Docker, it's basically like a VM wrapper. So you can see here that it just ran a normal chef run, and it has finished. And now I can actually see that I have a demo nginx image. So now what I can actually do is just do docker run -d to run it in detached mode, demo nginx.
Is your clock off? It says it was created 2 days ago.
Yeah, VirtualBox is awesome.
Okay.
I think that was the last time I restarted VirtualBox, and VirtualBox has. So, fun fact: the boot to Docker images do not have NTP. So have fun with that one, especially when you're running with Chef Server and it tries to sign your. Yeah, that's fun. Anyways, so now if I do Docker PS, you can see that I have a running container, running Chef init, and if I actually look inside this, I would see some unmanaged services. So it was that simple. You now have a container that ran a run list. So if we kind of go back here.
Can you show the Docker file now?
Yep, that's what I'm going to go. That's what I'm going to do next. So I'm actually.
Your mind.
Yeah. So I'm actually going to go Docker files, demo, nginx. Yes, I know it's a directory. Oh, that's right. I decided to dump all of my Vim plugins the other day because they were acting up. So, come on, get bigger. I want my text bigger. Okay, well, I will open up the Docker file here. And this is the Docker file that's generated for you. The first line specifies the base container. Base is not technically a Docker file term, hence it being commented out, but that's the line that Rebuild uses to determine what image it should rebase on. So if you started with Ubuntu 12.04 and you wanted to upgrade to 14.04, all you would need to do is change that baseline and run a rebuild. Then we have from demo nginx. Here we're going to add the chef directory. And then here is chef init bootstrap. And this is what's actually, so bootstrap is another chef init process that will launch chef client, but then once the chef client finishes, it will close down the container and return the chef client's exit code. So if chef client failed, that layer would fail and your Docker build would fail, and you wouldn't get an image. The Docker build would just kind of exit out. But if it succeeds, then you get a return 0 and Docker's happy. And this will prevent the situation where you have a crappy recipe that fails, but you still get a happy Docker image. Then here is this is the security thing. So after we've finished running your chef client, before it finalizes the image, it'll actually remove that secure directory. Everything in that secure directory, that's your validator, PEM, your encrypted database secret, all of that stuff. Which means that if you're running Chef Server, when you actually launch the container, you need to actually mount in those credentials back in to the container in order for Chef Client to run properly. This is a security issue, so you don't have your validator stuff and all of that on Docker Hub, but you can also just delete that line if you don't care. But by default, there's documentation that talks about how you would add those credentials back in, and once again, that's something that I'm trying to work with the Chef Metal team on, that all of that would be handled for you if you use Chef Metal. And then we just set up the entry point in the commands so you don't have to add those when you actually run the container. So if we go in here, you'll see that the first level of your configuration file requires the chef init gem. This is how all of the chef init libraries actually get into your chef runtime. Doing this prevents you from having to add another cookbook that does all of the chef gem stuff to get the libraries. So you don't actually have to add any cookbooks to your run list in order to use chef container. What you saw me do with the knife container docker init, knife container docker build, those are the only steps you ever really need to do. Node name, chef init node name. So the reason this is here is by default, Chef has various different ways to determine what your node name should be, but you want a way to be able to pass in the node name when you actually launch the container. And what this does is it has some precedence to look for different areas where you're setting the node name. Highest precedence is an environment variable. So when you do Docker run, you can pass in an environment variable that sets your Chef node name, and Chef will use that value as your node name. Otherwise, it will look for this .node, the contents of this .node name file. The .node name file is really only used when you're doing the builds. So this is the node name you would see on a Chef server when you would do knife container docker build against a Chef server. The reason we do this is so that knife container, because remember we talked about that a container can't remove itself from a Chef server. So by doing this, we have a way for knife container to know what the node name for that container should be, and then be able to remove it from the Chef server after your build is completed. But this file is actually removed when you do the build, so it's not actually in the final image. Then you also have a firstboot.json, which is like any other firstboot.json. So if you wanted to modify your run list, all you would do is come in here and add like a role or whatever you wanted to your run list. If you wanted to pass in some attributes, you can do that here too. But that's it. Like once you realize, like you can treat this Docker container like any other Chef node. You can set when you launch your image, you can do a -E flag to set the environment that you want it to be in, either in your Bootstrap here or when you actually do a Docker run. So yes, that's really the whole demo. Are there what other questions does everyone have? Okay, so I will be here if you have questions afterwards. Otherwise, you can definitely reach out to me on Twitter. My Twitter handle is @TomDuffield. Otherwise, you can just email me, Tom@GetChef. All of the stuff that you've seen here is all open source. It's all on our ops code GitHub repo. So if you want to do pull requests, if you want to fork it, whatever you want to do, go for it. So thank you very much.